In this example, suppose that an accounting firm does a study to determine the time needed to complete one person's tax forms. It randomly samples 180 people, and the sample mean is 22.7 hours. From previous studies, there's a known population standard deviation of 5.8 hours, and the population distribution is assumed to be normal. So you may assume that the underlying population is normally distributed. Step 1, we're asked to identify the distribution. Well, we're told already. There's no argument here that it is normally distributed. So in a normal distribution, we use this annotation right here, the normal distribution, about the mean, and our mean is 22.7 hours, with a standard deviation of 5.8 hours. How do we know? Well, of course, we're told that it's normally distributed, but there are two conditions, remember, that if we're deciding whether we should use a T or a Z distribution, we look at the sample size, and in condition 1, the sample is definitely greater than or equal to 30. So that condition is met. And we're told the population is normally distributed. We're told that in the problem explicitly. So since it meets those conditions, we're going to go that. So it says, if your distribution is a T distribution, what are the degrees of freedom? Well, the answer to that, if it is a normal distribution, we were told that we would write that our degrees of freedom would equal 0. So there is no degree of freedom right here. The degree of freedom changes the shape of the curve that we're dealing with in a T distribution. Since it doesn't apply in a normal distribution, we just simply give it a value of 0. Sample mean. We're told what the sample mean is. We're told it is 22.7 hours. Sorry for the extra dot right there. Population standard deviation is 5.8 hours. And our sample standard deviation isn't given, so we can just write NA. It doesn't work here. What is the error-bound mean? Well, that is the margin of error, and in order to calculate that, we're going to use Excel in order to help us do that calculation. So here's what we're going to enter. In Excel, we're told that the sample size, we're going to use the blue one down here for our normal distribution, sorry. And our sample mean is our sample mean is 22.7. Our standard deviation, we're using the population standard deviation, is 5.8. Now below the question, we're told that we should use a 90% confidence interval. So we enter in 0.9 right here. We find the critical value associated with that, which is 1.64. That is a Z value. Our margin of error is the important one right here, and our margin of error is 0.71108, etc. Lots of digits right there, but we're told to round that to 2 decimal places, so we'll give it 0.71 hours. The interval itself that we're interested in is found by taking our mean from our sample, 22.7 hours, and adding or subtracting that margin of error of 0.71. So when we do that, we get 21.99 hours and 23.41 hours. So if we're expressing our confidence interval, we would round that to 2 decimal places, and we would say 21.99 hours. Our population mean symbol right there. And we said also, what did we say there? I always have to look back. We said 23.41. 23.41. Quick interpretation of that, this is telling us is that based on our margin of error, based on our calculation, we would find that we're 90% confident that any time a person fills out that the known population for filling out one person's tax forms will be between 21.99, well, let's say 22, and 23.5 hours. Well, that's what we wanted, and so we're done.